and subtract 1. If you're in degree mode, it's not correct. So what do you get? It's cosine 1 minus 1? Negative 0.45? Close enough. Anyone else get that? Yes? Okay. So look at what this is saying. I mean, this is the fundamental part of this. Let me bring this picture back up. We're looking at the interval 0 to 1, right? We evaluated at 0 and got 1, right? We evaluated at 1 and got negative 0.46 or 0.45. And this is a continuous function, which means I have to be able to draw it without picking up my pencil. Why can you guarantee me an x-intercept now? Feel like I'm losing touch with all of you. Yes, the intermediate value theorem tells me that, but just in kind of, you're like trying to explain this to someone who's not in calculus, like, look at this picture, tell me why I have to have an x-intercept. I've got a y value that's positive, right? And I've got a y value that's negative. The two ends, one of them's positive, one of them's negative. And you have to draw a curve connecting those two, right? And you're not allowed to pick up your pencil. So if you've got to go from a positive number to a negative number, you have to pass through what? The x-axis. You must cross 0, don't you? So that function must achieve 0 somewhere. And therefore it has to have an x-intercept, and therefore that solution to that equation must exist. So when you're trying to explain this on a test or a quiz, all you're trying to show me is that there's a change in sign. Therefore, 3 dots like that in mathematics means therefore. That's a shorthand for writing the word therefore. Therefore, f of x, the function, man, I've got to get this figured out. F of x equals 0 somewhere in the interval 0, 1. Which means, what was f of x? Cosine x minus x equals 0. Somewhere in there, right? Somewhere in there. Which means that cosine x equals x, moving the x to the other side, somewhere in there. Which means there's a solution somewhere in there. Does it tell me what it is? Does it tell me what the answer is? Do I know the answer? No. But I know it exists. I know somewhere between 0 and 1, the answer exists. Yes, you're showing existence of a solution within a range from 0 to 1. And you may be sitting there going, well, who freaking cares? You show me there's an answer, but who cares, right? You're not telling me what the answer is, and I'll explain why this is important in a second. But do you understand the logic here? The first thing you have to have is what, though? You have to have what before you can even begin this problem? I mean, the equation, but after that, what's the first thing that we showed? Continuous. You've got to say first the function is continuous, because the continuity is what forces you to draw between the 2 points without picking up your pencil. So the continuity right there said, let's draw without picking up our pencil. Then these two things showed us we had a change in sign, and therefore we know we had to pass through 0. Yes? Okay.
So as far as like a written answer to that initial,
it would be your work. It would be, you would say, you know, the f of 0, the f of 1, show change in sign, and then your conclusion. So there's not like a lot of work for this. What's more important, I think, is for you to understand what's happening here, all right? Now, where's the value of this? Like, how in the hell does this work? So how many of you have a pretty good background as far as your calculators are concerned. Like you feel pretty comfortable. Could solve an equation. Can you solve an equation on your calculator? Anyone here think so? Can you try and have your calculator solve cosine x equals x? Whoever has a calculator. And if you have one of these fancy graphing calculators and you don't know how to solve the equation cosine x equals x, then it's just table candy. That's all it is. It's just to look good. You got this thing. You should try and learn how to use this. Solve an equation with it. Hey, I had to teach myself. It's not easy reading the manuals on this stuff, but you know. Okay, anyone got it yet? No? Yes? You got something? What do you get? Are you in radian mode? You are? What in the world is going on with this thing? Guess I can't solve anything because this damn thing won't work. Oh, my key was stuck. Okay, mine's working right now. Anyone else? You got 3 point something? Point something? Okay. And my calculator's like, I got 0.739. Anyone else get 0.739? No? That's what it's supposed to be. All right, well, I don't want to take too much of your time doing that, but let me try and get to the point of why this is what we just did is important. How in the hell did my calculator just solve that equation? There is no algebraic way to do it. Look, if you take this equation right now and you try and do this by hand, you are not going to be able to solve this equation. It's impossible to do that algebraically. The problem is that your x, if you're trying to solve for x, on the left side, your x is trapped in the cosine, isn't it? On the right side, you've got x, but you need x by itself, or you can factor it or something. So the only way to release the x from the cosine is to come in with arc cosine on both sides. But when you do that, you have to do it on both sides. So now you actually release the x on the left side, but now what have you done on the right side? You've trapped it with the arc cosine. And so again, you're stuck in this loop where it's really algebraically impossible to do it. So, but how did your calculator do it? Your calculator can only do what? I mean, what's the only thing that a computer knows? Right? Every computer in the world only knows this and this. On, off. Electrical signals there, not there. There, not there, right? That's all a computer knows. Zeros and ones. Binary. So does it sit there and go, cosine x equals x? Let me figure this out. The only thing your computer can do is arithmetic, addition, multiplication, right? But it can do it fast, can it? Your computer can add and subtract and multiply and divide so quick. I mean, it's mind-boggling, right, how fast it is. So here's what your computer does to solve this equation. It starts out with 2 points. And just for simplicity's sake, it starts out with 2 points, 0 and 1. Now, your computer can very easily figure out what cosine of 0 minus 0 is, right? And it would come out with an answer of 1, wouldn't it? That's what we got also. And then it would plug in 1, and it would get, what did we get, like negative 0.46? So your computer knows the same thing you knew. The answer is in there somewhere. So what it does is what's called, anyone who's going to be a computer science major at some point will learn this, is called the bisection method. And so what your computer does is it bisects this interval, it cuts it in half, and it looks at 1/2. Okay? So now what your computer does is it plugs in 1/2. And if you plug 1/2 in, it will come out to be a positive number. So what does your computer now know? It's on the right side. See, because your computer goes, I can test this is positive. I can test this is positive. No change in sign. Therefore, must be here because this goes from positive to negative, right? So what do you think it does now? It bisects that and does 3/4. What did I say the answer was? 0.73? And it'll turn out that it will be, if your computer does it, it'll be negative here. So what does your computer know now? It's in between where and where? 1/2 and 3/4. So what does it do? It bisects again. Now it's doing this like in nanoseconds, right? I mean, it does another test there. And that one would test out to be positive. And then it bisects again. And it keeps doing that until the interval gets to a certain predetermined tolerance. Let's say 1/1,000,000th. The 2 points are within 1/1,000,000th of each other. And then it says, take the average of those two numbers, that's the answer. And it spits out an answer. It gets as close as a pre-built, predetermined. Yeah, I mean, you can keep cutting the interval in half. But at some point, your points are so close together that the number of decimals between them is past what this computer's tolerance is set for. Yeah, I mean, it's just what the code is. Now, that method is the most primitive method for solving an equation by a computer, the bisection method. There are other methods that are more efficient than this. And the book even goes through one. And if you take any courses on numerical analysis, this is what you learn, is other methods to do things like this, solve equations. So, but this is all based on the intermediate value theorem. Yeah, I mean, with any real-world physical problem, you can only get within a certain tolerance no matter what. You know, if you're building a, I don't know, a car, right? You can put the alternator in there, and you know, there's a little wiggle room, and right, you're building an aircraft. I mean, you got to have tolerances, or got to be, yeah. So anyway, I'm just trying to get you to see that your calculator doesn't know anything you don't know. It just works a lot faster than we do. Okay. All righty. Well, I'm done with this section. I believe I'm done. Yeah. And I put this up earlier. The problems for 1.5 were given last class, weren't they? Okay. So I'm ready to move into 1.6. I used a solve feature on my calculator, but it depends on your calculator. I think your calculator is a TI-84, 85, 83. Yeah, I mean, I'd have to look at each of your calculators. You might have a numeric solver feature. Yeah, don't worry about it now. Okay, 1.6. So I'm going to look at the notes right now for 1.6. Remember, these were out of order. And this is the section on limits involving infinity. This is a pretty tough section right here. There's a lot going on. The two ideas in this section are as follows. And since there's two ideas, I'm going to show you both side by side. On the left side, I'm going to look at a function that does something like this. And I'm going to put, let's say, y equals 1, dotted line. That's like a horizontal asymptote. So where is that function on the left side headed as x goes to infinity? As x goes to infinity, doesn't